Well, hello again. Today we're talking about the remainder and the factor theorems. So we're going to talk about that right now. So the first thing you need to know is the remainder theorem. The remainder theorem says that if a polynomial is divided by another polynomial, the remainder is f of c. So in other words, if I'm evaluating a particular polynomial, and if I substitute a value in, that will be the same thing as the remainder, or vice versa. So an example of this, we're going to be using synthetic substitution, which is another way of applying the remainder theorem. We want to find f of 2. So what we're going to do is we're going to set up the problem like we're dividing by 2. So I create all of my coefficients of the polynomial, and I put the 2 in the box, and then I follow the whole procedure for doing synthetic division. When I follow the procedure for synthetic division, I hopefully, if I've done it correctly, get the numbers that are shown here. So you can go ahead and pause the video so that you can try it and make sure you actually do get these numbers. And if not, let me know and I'll have to correct it for you. But if you do synthetic substitution using the remainder theorem, you will find out that the remainder is going to be negative 686. So that means that if I were to substitute 2 back into my equation, I would get negative 686. So that's a way of figuring out other information when I'm substituting without having to worry about sign errors quite as much. Although, as you can see, it's very easy to make a sign error in the work here. You just need to be really, really careful. I could also, of course, do this with a word problem. What could be more fun? So I have 800 units of beachfront, that's the word that's behind there, property, and the tenants are paying $600 per week. Research indicates for each $10 decrease in rent, 15 more units would be rented. So that means I'm going to set up an equation. The equation would give me the R equation that's right there, but I'm going to kind of show you where that comes from because there was a question like this on our most recent quiz. So what I would do is I would set up an equation with one parenthesis that's going to deal with the number of units and another parenthesis that's going to deal with the amount of money. So since it says that there are 800 units, I would have 800 units, and if I have that particular decrease of money, I would get 15 more renters. So that's why it would be plus 15 times the number of increases. And then I'm going to take another parenthesis and use that for 600. 600 is the money. So if I decrease the money, which would be the $600 minus 10 times the number of decreases, that would give me my parenthesis for money. So the first equation deals with the number of units, and the first parenthesis and the second parenthesis deals with the number of money that I'm talking about. If I were to FOIL them out, I would get the equation that's shown up there. So usually when you see problems like this, you're going to have one equation that deals with number and the other equation that's going to, one parenthesis that's going to deal with the money and the other one that's going to deal with the number, parentheses. So if I were to apply this, it asks for the remainder theorem. So the remainder theorem says that we are going to drop the money down by $50. If we drop it by $50, that means it's 5 decreases of $10 each. So that means I would put a 5 in place of X and find out what I'm going to get. But in order to do it a little bit easier, instead of putting in a 5, which yes, we all know we could just put in a 5, it would be easy, I'm going to do it using the remainder theorem. So I'm going to create my equation in synthetic substitution. So if I do that, my 5 is going to go in the box because remember $50 is 5 $10 increases, decreases. I'm going to be left with negative 150 plus 1,000, and then positive 480,000. So I'm going to do synthetic substitution, and when I do that, I end up with my remainder being $481,250. So that means that if he were, or she, were to decrease the rent by $50, the revenue, how much money they would bring in, would be $481,250. So that seems pretty good to me, but that's 800 units, so I guess it might not be that good. I really have no perspective on that. But that would be how you would solve the problem. Not too difficult. Again, you could always just substitute the 5 in and get the same thing. Here's the factor theorem. The factor theorem says that if I have a polynomial And if I have something that's a factor, that means it will divide evenly. If it divides evenly, that means the remainder is 0, which also tells me that f of c, or f of whatever number I'm substituting in, is also going to be 0. So I'm going to use the factor theorem. And the factor theorem basically is going to say it's a factor if it divides evenly and if the remainder is 0. So I want to know if x minus 5 and x plus 5 are factors of that polynomial. So if it divides evenly, which means the remainder is 0, then it's a factor. If it doesn't divide evenly and the remainder is something else, then it's not a factor. So I'm going to set up synthetic division for both of them. So I'm going to, use the coefficients of our polynomial, which are there. And I'm going to use the 5 in the box. And then I'm going to do synthetic substitution or synthetic division. And when I do that, I find out that my remainder is 0. So since my remainder is 0, that tells me that 5 is a factor, or actually x minus 5 is a factor. But then it also asks me, is x plus 5 a factor? Well, I got to test it and find out. So I'm going to put negative 5 in the box this time. And I went back to the original one. And I'm going to see if I end up with 0 as my remainder. Unfortunately, as you can see, I don't end up with 0 as my remainder. So that tells me x plus 5 is not a factor because my remainder is not 0. And that's kind of says all of that. And then if I were to write factored form, I would use the x minus 5, which we know is a factor, and the depressed polynomial, which I get when I divide. So that would give me my factored form. I could have also tried the x plus 5 in the depressed polynomial and see if it fit in as well. We also would have found out that it's not a factor because it would not divide evenly and the remainder would not be 0. And then here's the last one. We're going to be finding out the value of k in a polynomial so that the remainder is 0, or so that x minus 1 is a factor of the given polynomial. It could be written in more than one way. So since I have the minus 1 on the bottom, I'm going to put the 1 in the box. I'm going to put the coefficients like I set up the synthetic division. But this time, instead my constant value, which is here, is going to be a k because I want to find out what is that k. Well, in order for it to factor evenly and have no remainder, that means this value that's over here has to be 0. So I'm going to complete synthetic division. And when I get to the last term, I know that the last term has to be k plus 2, and I do know that it has to equal 0 in order for it to have a remainder of 0. So I'm going to set up an equation that 2 plus k has to equal 0. If 2 plus k equals 0, then I know k has to equal negative 2, and that figures out the number that I'm missing. So basically what we just did is we applied our knowledge of synthetic division. And if we wanted to, we could do this with long division. It would just take much longer to figure out what things are factors and to evaluate different polynomials at particular values. We will use this, of course, when I see you in class the next time. Take care.